Assalamu alaikum. So today our lecture 9, and in this lecture we will inshallah start chapter 2, which is sequential experiments. So what happens that sometimes when we are performing different experiments, so most of the time the many experiments, they have consist of a sequence of sub experiments. So if we have some these sequential experiments, means we have experiments, sub experiments, and further. So it is sometimes better to represent these sub experiments with a diagram known as the tree diagram. So tree obviously has its root, then branches, and then nodes and leaves, etc. So they will represent our experiments and sub experiments. So obviously in this tree diagram we could have the probabilities of the events and conditional probabilities also. To represent our experiments and sub experiments. So this is the sequence. So this is start, and these could be repeated as many times as we have sub experiments, and this will be the last sub experiment. So it's actually outcome of entire sequential sub experiment. So these are sub experiments. So let's look at the example. I will copy it from the book and will paste here. So let's paste it on the next page here. So it's the continuation of the example 1.19 that we have done in the previous chapter. So we have we used A to denote the event that a randomly chosen resistor is within 50 ohm of the nominal value. This could mean acceptable. So we use the notation N not acceptable for the complement of A, means it is not within 50 ohm of the nominal value. The experiment of testing a resistor can be viewed as two-step procedure. First, we identify which machine produced the resistor. Second, we find out if the resistor is acceptable. So we have to draw the sequential experiment, and then we have to find out the probability of what is the probability of choosing a resistor from machine B2 that is not acceptable. So we will start with the root. So root will obviously have branches. So here we can clearly see these branches could be B1, B2, B3, the three machines which are manufacturing the resistors. So we know that probability from from machine B1 is 0.3, it is 0.4, and it is 0.3. So further, from each machine we will get the resistors, which could be either acceptable, not acceptable, A, N. Here also acceptable, not acceptable. From here also acceptable, not acceptable. Now we know the probabilities of acceptable resistor, which is 0.8. So obviously its complement will be 0.2. This is 0.9, so its complement will be 0.1. So this is 0.6, its complement will be 0.4. Now here we can see that these are branches, and remember that branches we on the branches we represent the probability of that event. So the probability of that the resistor is from machine B1 is 0.3, probability that the resistor is from machine B2 is 0.4, and similarly probability that resistor is from machine B3 is 0.3. So all these branches, just like here also, they are showing us the probabilities. So here what we have, the probabilities, and these B1, B2 and B3, these are called the nodes. Now as we don't have any further sub experiment, so the last one will be, these last ones will be the leaves as we have defined earlier. Now from here we can write down the probabilities, because these leaves are showing us the entire sequential sub experiment. So this will be B1A. So the probability of this one will be the product of all the branches from root to that leaf. So here we have 0.3 branch and 0.8 branch, so we will just multiply them and we will get 0.24. Similarly B1 not acceptable, so B1 0.3 and this 0.2, so it is 0.06. Similarly B2 acceptable, B2A, so B2 branch has the probability 0.4 and the acceptable branch has the probability 0.9, so it will be 0.36. So B2N not acceptable, so that will be 0.4 into 0.1, 0.04. So similarly B3 acceptable will be 0.3 into 0.6, which is 0.18, and B3N will be 0.12. So these are all the probabilities. Now we one more thing that we need to mention here is that these probabilities, all these probabilities are the conditional probabilities, because this is a probability of acceptable resistor given machine B1, acceptable resistor given machine B2, acceptable resistor given machine B3. Similarly these one also we have defined earlier, means these are complements, so obviously. So this is the tree diagram. Now the questions ask us to find the probability that we have chosen the resistor from machine B2. Now for B2 which is not acceptable, so not acceptable, probability of not acceptable given B2 is 0.4 into 0.1, which is 0.04. And obviously probability of probability of not acceptance given B2 is this is conditional probability 0.1, 0.1. So probability of the intersection of these two B2 and is, we have 0.04. So by the formula of conditional probability, probability of n given B2, which is equal to probability of n B2 divided by probability of B2. So from here probability of B2 will be simply probability of n B2 n B2 divided by probability of n given B2. So we have these two values, n B2 intersection of this is 0.04 divided by probability of B2 n given B2 is 0.1, so it is 0.4. Also we can see this probability from this tree is that the probability of that B2, probability of B2 we can is here. So this is also 0.4. Now let's look at another example. So again I will paste it from the book. So this is example 2.2. It says that traffic engineers have coordinated the timing of two traffic lights to encourage a run of green lights. So run of green lights means that if one car gets the green light at one traffic light, so that that car may get the second green light in the second traffic light. So in particular the timing was designed so that with probability 0.8 a driver will find the second light to have the same color as the first. Assuming that the first light is equally likely to be red or green, what is the probability that second light will be green? That also what is probability of that you wait for at least one of the first two lights. Lastly, what is the probability of first green light given second is the red light? The conditional probability of a green first light given a red second light. So again this is a very interesting problem. So we will start with the tree diagram. So again we will start with the root. Because green and red light here are equally likely, so means driver can get either red, say green one or red one. So this is our, so because they are equally likely and only these are two events, so their probabilities will be half. Next, that if first green light and the driver get the same light, so that the driver get find the second light to have the same color, means if it is G1, second is again G2, so its probability is 0.8. So the other option is R2, so obviously that will be complemented. Similarly, if it gets G2, R2, So this is red 1, second is red, so this will be 0.8 and this will be 0.2. So here obviously the final will be the product G1 G2 will be 0.4, G1 R2 will be 0.1, R1 G2 will be 0.1 and R1 R2 will have the probabilities of 0.4. So now it is asking us, first one is what is the probability of second green line. So probability of second green light. So second green light is here, here and here. So this is simply the sum of the probabilities of G1 G2 plus probability of R1 G2. So these values we have 0.4 plus 0.1, which is 0.5. So getting the second green light, we have the 50% chance. Now the next it asks us that what is probability of W, the probability that you wait for at least one of the first two lights. So we have to wait for one of the first two lights. So means probability of W. So obviously we will not get both same lights because we will have to wait. So we will have G1 R2 event, R1 G2 and R1 R2. All three events will be the union of all these three events will give us the probability of wait. So for at least one light, so probability of R1 G R1 G2 plus probability of G1 R2 plus probability of R1 R2. So we know these probabilities. So this is 0.1 plus 0.1 plus 0.4, which is 0.6. Now the last one, what is probability of G1 given R2? So probability of G1 given R2. So it is probability of G1 R2 divided by probability of R2. So probability of second green light will be, we can find it out here. So G1 R2 is obviously given from G1 R2 is given 0.1, but what is probability of R2? So probability of R2 will be can be easily find out because we have probability of green light, so that will obviously the complement of it. So 1 minus probability of G2, so 1 minus 0.5, which is 0.5. So probability of G1 given R2 will be just putting the values here. So this is G1 R2 is sorry, I forgot, G1 R2 is 0.1, sorry. So this is 0.1 divided by 0.5, which is 1 over 5, which is 0.2. So we have 20% chance for this conditional probability. Okay, let's see another problem for this tree diagram. So I will paste it here from the book. So this is quiz 2.1. It says that in a cellular phone system, a mobile phone must be paged to receive a phone call. However, paging attempts don't always succeed because the mobile phone may not receive the paging signal clearly. Consequently, the system will page a phone up to 3 times before giving up. So, if results of all paging attempts are independent and the single paging attempt succeeds with probability of 0.8, sketch a probability tree for this experiment and find the probability of failure, that the phone receives the paging signal clearly, a probability of F. So, sorry, this is not failure, this is for the founding, that the pager found the mobile. So, let Fi denote the event that the user is found on page I. So, obviously we will start with the tree diagram here. So, we will start with the root. So, we have that whether the phone is found in first attempt or it's not found, or we call it as F1 complement. So, the probability that the single paging attempt it will be found is 0.8, and obviously its complement will be 0.2. So, if it is phone is not found, it will again try. So, it will be the second try to find. If it is found, its probability is 0.8, and if it is not found, that will be the complement of it. This is again 0.2. So, again it will if it is not found, it will try for the third time, and we can see here that this is F3, and again the probability of being found is 0.8, and its complement will be 0.2. So, we need to find the probability that the phone actually receive that find the probability PF that the phone receives the paging signal clearly. So, the probability of being found is here a little bit tricky. In other words, so because it could be found on the first attempt, or it could be found on the second attempt, or it can be found on the third attempt. So, here we cannot actually go straight forward, because if it is found on first attempt, maybe second or maybe third. So, we have to go trickier way, that is we have to find the probability of its complements that it's not found in 3 attempts, and then we will take its complement 1 minus like this one, that F1 complement, F2 complement, and F3 complement. So, in this way it would be quite easier to find out this probability. So, this will be simple 1 minus probability of F1 complement, F2 complement, and F3 complement, because these attempts are independent. So, it will be 0.2, 0.2, 0.2 3 times. So, this will come out to be 0.992. So, we will stop here. We will continue with the next topic in the next lecture, inshallah. Stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuhu.